Hello, my lovely 8th graders. Today we are going to talk about 8P 1.1. If this will load, the first part we're going to talk about is subatomic particles, and that just means any particle that's smaller than an atom, which you all know to be. So protons are the positively charged, and then they're in the center of the atom. So in this picture, they could be the red or the gray, but we're going to say that they're the red because these ones here are red with a positive sign. So protons, positive, both start with P. Neutrons. Neutrons have a neutral charge. That means they have zero charge, and they're also located in the center of the atom. So in this one, they would be the blue because the other ones have the positive charge on them, making them protons. Then we have electrons. Electrons are negatively charged particles on the outside of the nucleus. So they are the yellow floating around out here. Again, they are negatively charged. So again, subatomic particles in our case are protons, neutrons, and electrons. Okay, so how to find the number of subatomic particles? The number of protons is the atomic number. So if you see here, it kind of spells out pan. If that helps you, use it. So the atomic number gives us the number of protons. The number of electrons is going to be the same as the number of protons. So whatever you put for the number of protons, you could also put for the electrons. Then for the neutrons, that's a little bit trickier. You have to take the atomic mass number and subtract the atomic number from it. We're going to do more with that in AP 1.2. But here's a little example right here. So on your worksheets and your packets, you guys should have this. And one of the things, if we say sodium, which its element symbol is Na, mass number is 24, atomic number is 11. So protons, we know the protons is the same as the atomic number, so protons is 11. We know electrons are the same as the protons, so that's also 11. Now for neutrons, we have to take the mass number, which is 24, minus 11, and we would put 13. You guys can do the rest of these on your own. You will also be doing this sheet, but I'm going to skip that for now and come back to it maybe later. So the next thing is states of matter, and we haven't talked about that a lot this year because you guys have been doing this since elementary school. So if we talk about solids, solids have a definite shape, okay? They have a definite volume, and if you look inside, the molecules, they're packed really close together. That's what helps give them the definite shape and volume. You can also see that they're moving, but they're not moving very much because they're so packed together, they don't have a lot of room to move. Next, we have liquids. So liquids have a definite shape. Okay, and they can take the shape, they don't have a definite shape because they can take the shape of a container. Think of when you put water into a cup. The water, it takes the shape of the cup. They do have a definite volume, though, because you can measure their volume. Now, if you look at the molecules inside, they're a little bit more spread out than a solid, and they're moving a little bit faster. Lastly, for gas, gas does not have a definite shape or a definite volume. And if you look, the molecules inside are the most spread out and they are moving the fastest. That's all for today. I hope this helps.